Hi everyone, I'm going to go over question number 49 from the chapter 14 bingo problems. This problem is really interesting. I'll read it first. It says, after landing on an unfamiliar planet, a space explorer constructs a simple pendulum of length 50.0 centimeters. She finds that the pendulum makes 100 complete swings in 136 seconds. What is the value of g on this planet? So, I really like this problem because I'm really like space stuff, and so the idea of calculating a force of gravity on a different planet is just so fascinating to me. Anyway, so we have this pendulum. I converted the centimeters to meters. I like working in meters. I always forget if I keep it in like centimeters to keep my units straight. So I just switched it. And then we know that the pendulum makes 100 swings in 136 seconds. So first of all, we're going to need an equation. And so the equation we're going to want to use is that our period is equal to 2 pi times the square root of the length of the pendulum over the force of gravity. Now, we have two unknowns, right? So we know the length, we don't know the gravity, that's what we're looking for, but we also don't know the period. But that's where this information comes in. So we know that a period is the amount of time it takes to do one cycle of, in this case, a pendulum. And so we just need to divide. So we'll want the seconds on top. So we'll divide 136 by 100. And that will equal our period. So when we do that, we end up getting that our period is equal to 1.36 seconds. So anyway, now that we only have one unknown variable, we can solve for g. And sorry, my air conditioning just kicked on, so hopefully it's not too loud in the background. But anyway, so back to this. So since we have a square root, we'll need to square everything to be able to work with it. So we end up with t squared equals 4 pi squared times the length over g. Now we'll need to obviously isolate g, so we'll end up with g is equal to 4 pi squared times L over t squared. So we just do that by multiplying g over, dividing by t squared. We end up with this. And now, since we only have one unknown variable, we can plug everything in, and we'll be able to find the gravity. And so, let's do that. So we get 4 pi squared times the length, which is going to be 0.5 meters, over the period, which we found out to be 1.36 seconds, squared. When we throw that in the calculator, we get that the gravity is 10.67 meters per second squared, right? Meters here, and then since the seconds is squared, per second squared. So that is going to be the gravity on this unknown planet, which would be really interesting because we know that on Earth, this isn't part of the problem, this is just kind of for fun, but we know that the gravity on Earth is 9.81 meters per second squared. And so, 10.67 minus 9.81. So that means that it's 0.86 meters per second more than what we have on Earth. So I think that would be so interesting to feel that, just to how different, we would sense that force of gravity, especially when we want to jump and things like that. So anyway, back to the problem. We used one of our equations for period, and then we used the length of the pendulum, and we were able to figure out the period to find out the gravity on this planet. So anyway, I hope you learned something, and I hope you enjoyed this video, and I'll see you in the next one. Thanks.